Hey, welcome everybody. Got John Ruzek here today. We're going to have a lot of fun talking about 3D printing and some of that related technology. But first, I want to ask you a few questions, John, if you're up for it. Just get the juices flowing.
Absolutely, Eric. Pleasure to be here.
So everything I'm asking you, prediction for 2023, okay?
Yeah, I mean, the market or predictions for 2023 is that I will get better at something. I don't know what that is going to be yet.
You don't have to predict all of 2023. Yeah, I got some specific questions for you. Do you think I'm going to need a 3D printer in the kitchen this year?
Need? No.
No?
Should you? Probably. Why not?
3D print a cake, right?
Yeah, why not?
It bakes the batter as it prints it, right?
There you go. That's true. I have used my heated bed as a coffee warmer in my office while I'm
Yeah,
doing work. So, yeah, extend it. Why not?
there's some brilliant. Exactly. Second question for 2023, will the AI overlords take over this year?
No, but they will change the way I think I work, and I think that a lot of people work as far as resources that we have available to what is the first thing I turn to when I'm trying to solve a problem? And understandably, Google is worried, right? Because even here recently, instead of firing up Google, I've fired up some of the AI tools that have come out. So will they take over?
That's right.
I don't know. They're gonna make an impact. I'll tell you that much.
So they'll probably leave this year to us, but maybe
Yeah,
we're worried about that next year, perhaps.
2024. I think we got to keep our wits about us. Keep an eye on them.
Great predictions, John. I really appreciate you sharing your thoughts on that. And I'm actually talking to a gentleman you know named Kevin Jordan here in a few weeks too about AI ML and some of the impact it's going to have on business in particular. So not taking over the world, but definitely a real impact to business. Stay tuned for that conversation. And if you can join us on that live call that we have, feel free as well. So thank you for that. Then maybe shift gears to today's actual topic. We are here to talk about 3D printing as a hobby, as a technology, as a even potentially a profession. First, introduce yourself to the guests. Obviously, I've said you're John Ruzek, but tell me a little bit about yourself.
Yeah, John, I am a software consultant with Improving. So that's my day job, but I'm a serial hobbyist. So anything that can kind of catch my eye and drive my curiosity is certainly a place that I'm going to gravitate towards. And 3D printing is one of the most powerful ways that I have found to scratch that curiosity itch. Just the wealth of capabilities and creativity that you can engage in, having the ability there right on your desk to see that come to life.
It's an amazing thing. And I guess probably from a pure audience engagement perspective. So I have 3D printers myself. I have a Bebo 2 and as well as an Ender 3 that I actually got to play with laser engraving, which we can talk about in a bit. What do you have from a 3D printing perspective?
So I just have one. It is a Prusa, and if you're ready for some word soup, Mark 2.5S with the MMU2S attachment. For a background, it started as a Mark II, and then fortunately with Prusa, as they've released new models, they release upgrade packages. So that's how you get all of the acronyms. So I have pretty much purchased every upgrade package that has been available as we've gone along to get to where we are today. Good old Prusa.
Exactly. They are super well known. In fact, my son, when he uses the printer, is their software for slicing. I use Cura, and so it's kind of interesting to see how the two of them work differently on the same printer. They do just think about it a little bit different.
Yeah, I'm a big Prusa slicer fan myself. Just it's what I used from the beginning, so it's just stuck with it as it went through their iteration of Slicer Prusa Edition all the way up to their own kind of branded release of that slicing program with Prusa Slicer.
And if it's what you have from a printer, then there's obviously some advantages. And for me, it's what I downloaded the free one that was on the internet, and they're both free, I know. But
well, and Cura is great, and in many cases, it has features and functionalities that come out well before they're available in Prusa Slicer. And so I have seen, and you do your research and look at it and think, oh, that's super cool, and then realize, well, Cura can do it, but not yet Prusa Slicer.
Right.
They catch up and eventually converge over time.
Let's talk a little bit about projects. Like you said, you're a serial hobbyist, and I know that you've shared many of the projects with me over the years at work, but what would you say is the most fun or interesting project that you've made? And it may not even be a 3D printed one, but I suspect it at least involve 3D printing.
Yeah, absolutely. So two pop into mind. The first major thing that I printed was a working model of a Chevrolet LS3 V8 engine.
Nice. Very cool.
It's a full engine block. The block itself prints as one piece. Took 64 hours to print, something like that. And so
64 hours is amazing.
Yeah, exactly. Yeah, and used by the filament in 1 kilogram packages, it used 700, something like that. So that's one where you hope it doesn't fail.
I don't know that I've ever printed something for longer than 12 hours because I just start to get nervous when I pick a shape and I do the slicing and it's like, it's going to take 24 hours. I'm like, let's do something different. Let's make it half the size.
Yeah, exactly. we're gonna print at different layer heights or something. We're gonna reduce the infill. But yeah, that was the really fun thing. So it was block itself was a 64-hour print, and then all of the other parts. I mean, I think it was 200 hours of total print time across all the different jobs, and then some assembly, some
Yeah.
post-processing cleanup. But at the end of the day, you can actually put a motor on it and see the pistons moving up and down, see the valves opening and closing, and it attaches with magnets so you can disassemble it and break it down all the way to the crankshaft and the camshaft, and it all
Right.
looks and assembles like the real thing.
That is pretty amazing. I, as a kid, had a regular model V8 engine, and so I assembled the whole thing, glued the whole thing together, and nothing turned. That's not cool. It was supposed to. And so I actually tore it apart and rebuilt it. I'm like, now I'm a real mechanic, right? Because I tore apart a V8 and rebuilt it, and it worked the second time.
There were many reprints of parts as try to get things together, and something didn't print right or was needed to be slightly adjusted, and so tolerances weren't just right. So yeah, a lot of reprints of some of the parts to get it to all work. But once it's working, it's a pretty impressive sight.
This is not a tips and tricks about 3D printing. We want to kind of elevate the conversation to some of our kind of where we see that going. But before we get there, talking about kind of that part, I printed so many things where the parts are supposed to fit together. And in the designer, you're very precise, right? The hole is exactly the same size as the peg that fits in the hole. That's not how the printer works, though, right? And so with a little bit of warping, a little bit of sagging, how do you get it close enough in the design so you're not actually giving up the tolerance is not too high, but also so that an X-Acto knife can fix it and they fit together. So
yeah, the post processing. I mean, we get closer and closer to where the printers are incredibly accurate. But you're right, there's always going to be some post processing, and I've run into that with the second thing that came into mind was the community around it is just unbelievable.
yes.
So I connected with someone who redesigned watch movement in 3D printed parts. So I have a handful of his designs that I have printed for some pretty cool watch movements that he looks at pictures and specs and will redesign all the gears and make it almost identical and scales it up to where it can actually run and mesh with 3D printed parts.
This is a part of a toy that I printed, and so
there you go.
The toy had broken and it needed a new post that was maybe 3 millimeters with a 1 millimeter spike on the end to fit in. Well, my printer can't actually do that because it was just such a tiny little part. Finally got something close enough and the toy was repaired, but once you get down to the individual millimeters precision, my printers don't get there.
But just the fact that you can do that,
yeah,
right? I mean, a toy is broken. All right, trash the whole toy and buy a new one.
Right.
The manufacturer's not going to sell you that little plastic piece.
Nope, exactly.
For a $10 toy. And I mean, okay, a few minutes in a design software and a couple minutes on your desk in your house, and
exactly.
New part.
Yep.
Gives new life to things. The fact that we're there is just amazing to me.
For me, with the printer, the things that I have printed have been things that you really can't go out into the world and get. I have a almost 70-year-old house. There's a little piece of trim that went around the doors. I printed it because you can't go to Home Depot and buy 50-year-old baseboard trims, but you can model it and you can print it, or light switch covers that actually look like they belong on the light switch as opposed to the plastic ones that Home Depot sells. Things that don't exist in the world, in the market, they might exist on some of the downloadable models. Replacement parts for cars, right? Old cars that have a piece of plastic molding that's gone. For me, that's really the value.
The fact that, I don't know, I need a case for some little electronics project that I'm doing. And okay, I got it. To your point of, I got it close, but I know within an hour, all right, I got it close, or all right, I need this adjustment, I need this. Okay, printed it maybe a low quality, and then all right, we could iterate the prototype and then boost the quality to print the final object. Just the fact that we have that capability on our desk now. I mean, what are crazy prices for things like Enders and things? I mean, the accessibility is just unbelievable.
Yeah, the Ender 3 that I have, I got it, like I said, more for potential laser work, was $180, I think, is what I paid for it. And you have to assemble it, but you assemble it, and I did a test print, and it was from assembly to actually printing something, almost no knowledge was required other than how to print a screwdriver. I obviously have some latent knowledge about how to do 3D printing, but none of that was required for this thing. It did a great job, basically, with some very simple instructions, which would have been absolutely, you would have never spent $180 on a 3D printer, 5 years ago, because it would have been trash and it would have printed trash.
Yeah, you'd spend $180 on the hot end because they just weren't that many around. It was a niche thing, and as it's come around, and competition and availability of parts and everything has just driven the cost. I think I saw Micro Center, I don't know, it was $99 $99. It was some discount on I think that Ender 3. It was get you in the door. We'll sell you a 3D printer for $99.
Yep, I think that's what's going to be interesting about our conversation today is kind of where this is headed. The Ender 3 is a single filament, single hot end type of traditional 3D printer. I know there's a huge aftermarket, or even within the company, there's no shortage of what I could do to it if I wanted to. The Bebo 2 that I got, which I got back in 2020, is a dual head printer. Can actually load 2 filaments up at once, a support and a primary or 2 colors, and it will print both of those at the same time, basically. Not exactly, they take turns, but compare that to your Prusa. You've got the multi-material.
Yeah.
How does that work compared to the Bebo?
Yeah, so you have a single extruder, which solves a lot of the problems of those dual extrusion nozzles where you've got to have them perfectly aligned and offset,
Yep.
as well as it does limit the effective size of your build plate because you can't use the whole thing.
Yes, exactly.
So that solved a lot of the problems there. So just at a high level, as it gets to filament changes in the slicing software, when you slice it in Prusa Slicer, you can insert filament changes or model a single solid object as multiple distinct parts that then you can set different properties of the filament that you want to use. And when it hits one of those changes, the negative of it is it needs to move the printer head out of the way of the part that you're printing. It needs to eject the filament that you're currently printing, and then it will load the next color using kind of a cassette at the top that slides to pick up the next filament. Yeah. The negative there is that process, while pretty good, as it loads that second filament in, it now needs to purge that nozzle. So they've come up with the idea of the purge block that just basically prints a waste block of filament. There's some interesting solutions to that where you can print that waste block into another model that you get unique colors, like almost like a rainbow pattern on that model, and so that can be kind of fun. But ultimately, you're wasting filament as it does that purge and reload. That being said, over the course of a print, if you're thinking about every single layer, sometimes hundreds of layers, if you've got multiple colors on each layer, you can easily get to over 1,000 filament changes in the course of trying to print something. That's 1,000 opportunities for it to have an issue, and it's not perfect.
Right.
So for one of those long multi-material prints, I get a lot of notifications that something didn't go right, or you got to babysit it a little bit. So I would say it is awesome to have, but I mostly print single filament and leverage that with just the ability that I can have 5 filaments loaded, and in my slicing software, tell it when I create the model, use filament 3, and it does a pretty good job of picking filament 3 and using that, but no changes while I'm printing the object.
So it's funny you say all that, because one of my favorite test prints for my dual extruder is a chessboard. Not a full, it's actually only like 4x4 squares, right? Not a full size. But it's when it prints it becomes one solid black and white pattern if that's the filaments I pick. That sounds like a nightmare to print on yours because of just so many, every single layer has 2 colors and every color is 50-50 on the thing. And even with the Bebo, there's a time delay because it will let the hot end that's not doing anything cool off so it doesn't drip.
Right.
And so you're at least waiting for the hot ends to heat back up between color changes. But that's it. I'm not waiting for what you just described where it has to go unspool and purge and then reload. And so I imagine just time multiplier, right?
Very much so. It definitely extends because, I mean, I would have to average it out, but I don't know, 20 to 30 seconds per filament change. So per layer, potentially multiple times per layer, just waiting 30 seconds to complete this project or more. One of the really neat things about that, I mean, the multicolor prints, and you get to see some cool things. But the filament material, multiple material prints has some unique opportunities, especially with soluble filaments, where you can print supports that dissolve and have I have the hips,
which dissolves in the D-limonene. So
that's nasty stuff.
I think I told you, What was funny about that, though, is I did not realize that HIPS has to pair with ABS. You can't do bonding between HIPS and PLA because they are different temperatures. And so there's the water-soluble support material that pairs with PLA, but is also twice as expensive.
Yes.
So I bought HIPS, and then I tried to do something with PLA and getting spaghetti every single time.
Yeah. I've not tried anything besides the water-soluble. I will say the water-soluble, the issue with it is, if you've ever used a glue stick, it is an extruded glue stick that is built into a plastic thing. It will start to turn into a glue stick sitting on your desk.
I bet so, yeah.
So if I ever want to do it, I have a dehydrator in my office, a food dehydrator for making beef jerky, but I've taken all the shelves out of it, and it is used for dehydrating filament, pretty much specifically for that filament to keep that dry, and it works great. But if it is a long print, even in the time it takes to print for 4 hours, 5 hours, as it's sitting there spooling in, it starts to absorb water, and you'll hear your hot end popping as water is boiled out of the filament that was just perfectly dry 2 hours ago.
Right.
So that has not been completely solved yet. I know there's other solutions, but at least there's always challenges and opportunities to make improvements and tweak and get your hands dirty.
And I think that's where, as we tend to shift this conversation to those opportunities, we call them 3D printers because they have an X, a Y, and a Z axis. And now 4 and 5D printers because they're adding new axes to pivot the shape or print. We talked a lot about using multi-material for support and dissolvable. Well, another solution is just rotate the shape so that you don't actually need support. You just start printing on the side of it. If you had the unlimited budget to go buy something, what's that next printer that's doing these kind of cool things? Or building, probably, not buying.
So you sent me the link to the research project to convert my Prusa, add some stepper motors and things to it to make it a 3 or 4 or 5D printer, right? I'm waiting for that to come to an ender level because I think it's in its infancy where I want to play with it as a serial hobbyist, but I am not. I have my Prusa, and this is what I tell people. The nice thing about the Prusa and why I spent the money from the beginning is it is to a point now, by and large, it's click, print, get part.
Yep.
Where I've heard a lot of people click, print, something fails halfway, try to adjust the bed, level it, try it again, something else went wrong. Credit to them, it is like my desktop inkjet printer, where when I print something, I kind of get what I expected without much fuss. When this comes down to an ender or something, I'm not willing to make the investment right now because it's only set up this particular example for Prusa. When we get to an ender, maybe it's worth the $180 investment and some extra parts to have this thing. That being said, I'm more interested in metal.
Makes sense. Metal, a couple different options there for the prosumer market, not the consumer. Are you thinking the metal filament that you send off? Or are you thinking like ablation? Where's your mindset in metal printing at home?
That special filament with the printing and then sending it off to a sinter or kiln, whatever, I don't know exactly how the process works, is pretty cool. But some of is it SLS, something laser sintering, where the aluminum powder with a high-powered laser that literally just welds it layer by layer and you have a real metal part. I think that making it to a consumer level is the next real game changer.
Yeah.
All right, I can print this 3D printed watch movement in plastic, but it has to be blown up because there's no way to print a mini metal cog wheel that isn't flexible or something. But if I can print a watch movement at that scale, or at least just print something with the tensile strength and flexibility strength of different metal alloys, I think that's the next massive leap.
And I've seen the one, like you said, where it's sintering the metal. And we haven't talked a lot about, because all of ours are
FDM, filament deposition method,
versus the ones that emerge the product from the vat.
Yeah, the resin ones.
Versus, so we got the FDMs that you and I have, right, that are depositing material. Then you have the resin printers, which are in the pool basically curing an epoxy type of material and with a UV light to produce a shape.
Absolutely.
And then you have the next generation out of the sintering. And then, of course, even further, I hinted at earlier, the ablative, where you've got the chunk of aluminum and then the laser just leaves behind what you want. Literally carves a shape out of a piece of source material, which at the very beginning of the call, I mentioned I was using laser engraving. I'm not doing that. I'm doing cardboard and wood and maybe some leather. Definitely no plastic, definitely no metal, and my laser can't etch glass. My laser energy is focused, see what I did there, on the safe side of laser, not the fun side.
Yeah, not mess with lasers. However, we were in a toy shop in Helen, Georgia, if anyone's ever been there, and bought my son a little toy. One of their offerings is they will burn whatever name you want onto one of their little word. And so we had his name right there, and they got a mirror up above the counter to where you can see into the laser engraver as it burns the name onto it. So that was super cool. So got a kick out of that. And they're making money doing that. They got us to pay an extra $10 to have it engraved.
If I wanted to throw away money, I would definitely look at a proper laser engraver, but the add-on to the Ender can do, assuming that's wood or, again, safe materials only. Do not laser etch plastic unless you want toxic fumes in your house. No.
And don't do it in your bedroom.
Exactly. Yeah.
There's been some interesting stories about that.
So even etching wood will produce smoke is toxic. So, but at least wood smoke is not as quickly toxic as plastic smoke. When you're venting it outside, you're not killing the wildlife, for example. But it is still so fun. And this is, again, one of those things. It's fun to watch, and yet you can't watch because it's a laser that you will absolutely damage your eye if you watch. So I actually used my, when I had it set up on on the Bevo, I actually used the camera to watch it. I have set up on the 3D printer, and I'm like,
Gotcha.
it might be bad for the camera too, but that's okay.
I'd rather lose a camera than your eyes. All of those different attachments and the whole idea of G-code driven machines coming down. I mean, all used to be CNC machines. If you were a machinist, you would use it. My first ever experience with G-code was learning how to use a lathe in college in the shop. And I was a software guy, but trying to figure out how to use this and get it to move tools. And I thought that was the coolest thing.
Yeah.
And I would only ever see it in a college shop lab setting. And a few years later, I've got that sitting on my desk. So pretty crazy.
You mentioned CNC, and you mentioned thinking about the Prusa and the way it can change filaments automatically. We were just recently talking about a printer that actually can change the whole hot end automatically. And you and I even looked at a device, I'm not sure if it ever made it to market, that could change out the actual tooling. So it could be a 3D printer or a CNC machine. Remember that one?
I had seen that, yeah. So the one that you're referring to is the new Prusa XL that is still in development. Actually, they just released an update yesterday on where they are in the development and beta testing stage, where, yeah, instead of moving and swapping filaments down to the same hot end, it will just go and grab a already preloaded hot end
Right.
with the new filament in it. I'd love to see it. It solves some of the problems that I see with mine. I could see it causing or opening up a whole another host of issues as far as calibration and everything is concerned.
Yeah.
But I'm excited to see it.
I've also seen some YouTube hobbyists where they'll 3D print the part and then put that part in the CNC machine to get to the final tolerances. Some of that post processing that we were talking about earlier. I use an X-Acto knife. They use a CNC machine. It's like, so we've got this block of plastic, and they obviously printed it with no solid infill, right? And then they can basically grind it down to the exact tolerance. Which, if that prototype comes to market, it's going to do it all for you. It'll print it, and then it'll shape it, and then it'll laser and etch it, and then it'll eject it for you. You won't even need to be there. It's kind of like the conveyor belt. Have you seen the conveyor belt printers?
Yeah, I have.
So it prints the part, and then the conveyor belt drops it in the bin, and then prints the next one. So you can print 500 copies of something, and it's a more than 3D printer because the conveyor belt itself becomes one of the axes that the printer is programmed on.
Yeah, I have seen those. Yeah, infinite printing or whatever.
Yeah.
It'll just keep printing parts over and over and over again without having to reset or do anything.
Yep.
Yeah, those are kind of interesting and fun. Yeah, and then you see like Prusa and they set up farms where they've just got to try to solve that with a room full of dozens or hundreds of printers just all going printing parts the same way. It's very cool. It does get interesting. Like, at what point is the cutover on a project like that, right? Because we all talk about that it's additive manufacturing. Start with nothing and just put down the plastic or the material that you need to create said part, as opposed to the CNC, which I don't know, reductive manufacturing.
Yeah.
The proper grammar escapes me on that one, but start with a big block and then cut away till you get to the part.
Yeah.
At what point is the cutoff where if I'm going to be then cutting away material,
right,
do I just print a solid block of plastic and let my CNC create the finished part?
Yeah.
Or is there a value proposition to letting the additive process get close
and then refine,
and then just having a CNC take it down to, as opposed to a granular or less and less granular passes with a tooling,
right,
to a non-finish cut to then a finish cut.
Yeah, that's what this one project was doing, was just kind of cleaning up the tolerance just to make the parts exactly the same size every time, because the 3D printer does not guarantee that. Yeah. Whereas the CNC machine has the blade more or less guarantee everything.
If we could all be so lucky, I'll get a CNC, a Haas machine in my garage here next week. We'll see what happens.
Exactly. That's what's kind of fun about this whole thing, right? Is it's just each time we read something, somebody's figured out another way to do something even more. Rotating the hot end to make it multidimensional, rotating the build plate. Is the turntable printing real, or is that just imagined, where the actual build plate can rotate for printing radial things? Have you seen?
I have not seen that yet.
Right.
It makes sense.
Yeah, you can print a perfect curve if you can rotate your build plate.
Yeah, if you just spin it in a circle.
Yeah.
Yeah, absolutely. So there's we're talking about opportunities, right? That an interesting solutions to problems, and having, like I mentioned, the parts availability and prices come down to where you can try these things out in your basement if you want, right?
Yeah.
Like, all right, this circle isn't a perfect circle because ultimately the movement is a series of straight lines, for example.
Yep.
Well, let's just move the build plate and make it circular and have it move it in a perfect circle and
right.
keep the extruder right where it is. Yeah, so
Or
and then prototype it and build it using what are commodity parts
yeah,
right now.
and as you get more into multi-material, even think about the printing the metal wiring for circuitry along with the plastic so that you actually end up with fully functioning devices because you've got all the materials you need, or some parts are rubber and some parts are plastic, and so you've got flexible parts built in. So all these kind of concepts are conceptually possible. There's physics problems there, right? Because metal and plastic and rubber all have different melting points, and so some things to think about. But we know the technology is headed in that direction where it can start to do, and for that matter, scale all the way up. We're not even going to talk about much today, I don't think, but 3D printing houses, right, with concrete. It's this exact same
Yeah.
machine that's in our house, just giant and hooked up to a concrete truck.
Yeah, absolutely. And that's the interesting thing is I'm just fascinated with these things sitting on our desk is we talked about in the office, I have some family that work for some military contractors and they're like, oh yeah, we've been doing this for years with metal, with all of these things. They're the size of a warehouse and can print satellites.
Right, rocket parts.
Yeah, they print rocket
Yeah.
bodies, right? And as they're printing them, they're measuring them and generating certifications and all the stuff that is required for the government. But yeah, so that technology exists, is scaled up, and I guess I'm more looking for how does that scale down and eventually make it into the hobbyist in
Yeah.
my, because I would love to build a SpaceX competitive rocket in my garage, but
Need a bigger garage.
yeah, I need a bigger garage. But more realistically, to your point, I think I could print a metal screw or a bracket or a part to fix something that
Right.
that broke and I can't easily get parts for.
So we've talked a lot about the future of 3D printers and where they are headed, and we probably can't even imagine. You know, you and I, we've come up with some things, we've seen some things, but it'll still surprise us. Let's flip back to today. What are you working on right now? What's your project?
So my project right now is more along the lines of documenting all of my projects. I have a YouTube channel that is not real. I post videos every once in a while. You get some, I've learned that with the social media, you get some that take off, some that get 3 views. You think this is the coolest thing you've ever done, and 4 people like it. You think this is simple, and 90,000 view your video.
So like and subscribe to John's YouTube channel.
Yeah, I would love to give you the name, but it's my last name spelled backwards. So, yeah, provide a link to it on it. It's not great branding. But so setting up and trying to find a different way using some of the tools like Octopi to capture images and hooking up a more high fidelity camera with time lapsing to try to create a workflow to more easily convert some cool content around when I print something. Can I convert that into, I don't know, a TikTok video and
There you go.
Instagram
Right.
reel, a Facebook short or YouTube short,
Yeah.
whatever it is, just to start getting more of that out there. And in the process of that, I've had to print parts to mount the camera. I've had to do some wiring, soldering, figuring things out. So you come up with a goal in mind, especially in the hobbyist thing. The 3D printer has been an integral tool in getting to that end state.
It's kind of brilliant, right? Like use the tool to build the parts to make the tool better. And that's exactly what happens with 3D printing. Is even my printer, I'm pretty sure some of its parts were printed, like even the original parts that came with it. But like you, had to print a mount for the camera.
Yeah, and I'm looking at my Prusa right now sitting next to me, and all of the parts on it that are not metal, that are plastic, were printed. And back when I bought it, they've got a farm that I think it was every day one of their printers can print the parts for a new printer. But I remember with one of the upgrade kits in particular, you received all of the metal parts you needed. I think it was a hot end upgrade, so you got the new upgrade, and they sent you a 200-gram spool of filament. And the first thing was, do not disassemble your printer to try to assemble this. Go to this website. Here's the STL files for all of the stuff you will need to complete the upgrade. We've included filament for you to print them. Once you've got them successfully printed, you can start disassembling your printer and adding in the upgrade.
That was very funny.
So,
because somebody also did that. They're like, "Oh, I got it. I'm going to take my printer apart."
Absolutely.
No.
Yes, absolutely. Never open in that box, the piece of paper sitting right on top.
Right.
Warning: do not disassemble your printer before printing the parts.
That is, I wonder where else we're going to see that. That's kind of that something else you're going to buy, and it's just going to come as a spool in an STL file.
You do wonder about that. Like, is there an opportunity somewhere where you want to buy some widget, and it's $50 if you want the widget, and maybe it's got some metal components or things in it, or it's $10 should you happen to have a 3D printer? We'll send you the parts and some plastic, or just, hey, it's $10. We've assumed you've spent $10 on whatever color. You can make it whatever color you want. You can make it. I'm sure that's a problem that's already been solved. That I just haven't done the right Google search to stumble upon that.
It reminds me of the brand store that Prusa has, where you can download name brand replacement parts if your video card needs a new plastic component.
Right.
Back to the original point of the conversation, things that you just can't can't get from the real market, now you can get from the 3D part market. We've come full circle.
And there's a whole conversation then on that, don't need to touch on today.
Sure.
Right, because there's so much more is just then the legal aspect of that, right? If I spend a bunch of money designing and prototyping and I got my perfect models and someone goes, yeah, all right, great. Click, 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 click. Here's the STL. If you want to reverse engineer this, go ahead and print it. That gets into
copyright law, patent law, still apply here.
Still apply, exactly.
Just because you can doesn't mean you should.
Yeah, so there's a whole other world and questions and things that this capability opens up, and it's just fun to stay ahead of all of that.
Right. I think one of the things that's fun talking about this is that the conversation doesn't end. You and I have had a version of this conversation so many times over the years that we've known each other, and been kind of maybe just some parting tips on people who are maybe just starting or curious when they can't ask you or me, or they can't spend hours listening to us talk about it. Where do they go?
I would say if you're at the hobbyist level, buy the best printer you can afford, but don't go nuts. If you're at a hobbyist level, there are unbelievable printers out there in the $3,500, $4,000 range. You don't need that. I will put my recommendation behind Prusa's because I love it. I think that I'm very glad that I spent upfront to get it, because I have, in the hobbyist world, there are many, many times where I have spent double the cost of the product because I could do it cheaper myself building it. That $1,000 drone is way too much. Let me spend $2,000 building one myself. Buy the best one you could afford in that realistic range. That being said, if it's an Ender or whatever, great. I would highly recommend, and Eric mentioned this earlier, if it comes in a kit, do the kit. You're going to make mistakes. He mentioned they're pretty easy. They're pretty straightforward, the instructions and how things have got put together, but you will learn so much about how things work when you put it together. And when inevitably something loosens up, the leveling isn't right, the belt or a motor isn't, having put it together, you will have learned how to take it apart and how the parts integrate. If you're getting into this, it is certainly, there will be tweaks, there will be adjustments, there will be things. If you start off by having to put yourself through the process of learning by building, you're going to be ahead of the game.
That's a great point. Once you get a piece of filament stuck in a corner of it that you can't reach with any tool, guess what? You're taking that thing apart. I think the other part there that's probably worth reinforcing is this is still a hobbyist world. There's not a printer that anyone should run out and buy and think that they don't have to learn a whole bunch of stuff to make it good. So even if it's pre-assembled, even if it's a very reliable brand with self-leveling and all the bells and whistles, you're still going to have to learn about bed adhesion. And do I use tape this time or glue this time? Or does the bed need to be heated, and to what temperature, and the filament? There's just all that stuff and you can keep your life simple and only learn it for one type of material, but you still got to learn it, right? It's not nothing is just literally take it out of the box and hit a button and
absolutely.
The replicator in Star Trek, the thing appears.
And to my point of click, print, get part with the Prusa, yes, the technology on the Prusa helps quite a bit, but getting to that point, I'll tell you, I buy the same 3 or 4 types of filament. I have profiles that set up and I know that they work for them, but getting those dialed in and all of those settings takes time. And so humidity changes. Do you want an enclosure or not? So temperature swings in your office I'm in a basement, so during the winter it's cooler and in the summer it gets hotter. So even that kind of comes into play. I think start off with the kit and just plan on a journey of learning to get it right. But once you do, the opportunities are kind of endless, and especially with one of the name brands and Ender a Prusa, there are no questions that have not been answered, and the communities are going to be just incredible in helping you solve any of the problems. Or when you're new at this, getting into it, there's people to help.
Well, very cool. Thank you for those parting guiding words for folks that might be interested in getting involved or are involved and trying to figure out how to what next. I'm sure John and I will do this again sometime. He has a YouTube channel, so maybe we'll do some crossover episodes. And from there, thank you all for listening. Thank you, John, for joining me today.
No, thanks, Eric, for having me.
Until next time, I'll talk to you later. Thanks.